Hi everyone, welcome to our workshop. So we are from ETSU Statistical Consulting Lab. I am Rasul Islam Rani, and this is my colleague. So we're gonna do the presentation today and do the workshop. And first, I'm gonna talk just a little bit about SCL, our lab. Then she's gonna come in and present our workshop. Then I'm gonna do a demonstration in R.
Share your screen.
What?
You gotta share your screen on Zoom.
Oh. So as I said, we are Statistical Consulting Lab, and we are located at the Gilbert Hall, 3rd floor. So if you just come to the office, and it's one of those rooms inside the office, and we are open Monday to Friday from 10 a.m. to 2 p.m. Except on Tuesday and Thursday, we have class from 11:45 to 1. So we are not available at that time, but every other time from Monday to Friday, we are available. And this is our YouTube channel. And this is our email. So you can always reach out to us with this email address. So what do we do in the lab? So we provide consulting on research, design, statistical analysis, and data management. So we always have 3 consultants in this semester. So all of our consultant is proficient in Python, R, and SAS. And we can help with other software too, but we have to look it up sometimes. So we provide help to faculty research. So we can talk about methodology and analyzing your research and analyzing the data. And we also do the same thing for students, and sometimes from high school students to PhD students. So we cover faculty and all kind of students, and we can provide all kind of statistical consulting. And next, Sachi is gonna give you the slideshow for our workshop. Thank you.
Hi. Hi. So the reason for our workshop today is that we want all of us to be able to work with a comfortable data so that we can do good analysis and make conclusive and better decisions. So today our workshop will focus on what are some of the messy data that we have and how to handle it, the missing values and outliers, how to make decision whether to retain them or to drop them or like remove them, and also how to prepare our data for accurate and reliable analysis. So what is messy data or bad data? Is any data that have some of these problems like missing values, wrong entries, duplicates, and inconsistent format. Why our data needs to be of quality? Because it will affect our results. If our data is so bad that it has some missing values, some important details that are missing, our analysis or result is not fully conclusive that this is the true result. It kind of affects our credibility of what we've done. And this can lead to wrong judgment. So what we are supposed to do when we get our data, either by ourselves or from an external source, is to always filter the data to see the data, how the data looks like. What are some of the variables in the data that will help me answer my research questions? And what are some of the variables that are in the data, but I did not need it? So with them, you just have to delete those variables. So we look at some of the data errors and inconsistency. Some of them are the incorrect entries. So let's say the data value is 190 and you wrote 19. So this one becomes like an incorrect entry. And some of the variables, the values, we tend to duplicate it, make it so many times. Instead of maybe 19 appearing once, it appears more than once. And a column whereby is full of values will have one cell being like a test. So that makes the column, that particular column, inconsistent. So duplicated data, as I've said earlier, is like making it more than once. So with that, and some of these are caused by when we are entering the data and by mistake, we just entered the wrong, the data twice or more than once, even though it appears once. And sometimes when we are merging data sets and both data sets have like similar, some of the rows being similar or the same, it can lead to a duplication. And when maybe you are copying and pasting. And so what are some of the risks in the duplicated data? It inflates our count. So let's say you did a research with 400 people, but in your work, your data, you're seeing like 500 observations. So it means that probably there has been a duplication of the rows. And this will lead to wrong calculations. So let's say if I'm taking the average of a particular column, because the number of rows has increased, my average tends towards increase or decrease. It's not consistent. And data leakage is when you have the same row appearing like for machine learning, like a training data and a testing data. So for the testing data, I may say that, you may make conclusion that is correct, but even though it is wrong because it has appeared more than once and the data has been able to read it. So inconsistent data, some of them are like for example, in one column, you are looking at cities. And your cities, you have Paris, you have London, you have Johnson City. Yeah, but in Paris, some of them are spelled as like this, capital P, and some with small p, whether it may count it as twice, like two different things. So it makes the count not being correct. And when there are typos in your data, even though you want to write female and you wrote this, so with that, it seems it to be two different things. So that brings the inconsistency in our data. So how to correct this? We always have to make sure that the entries that we've made in our, let's say if I'm using Excel, the entries I've made is always correct. You have to go over it to check it. And you also have to remove duplicates. And you also have to standardize your format. So in this column, if it's currency, you know that it's currency for that column. In that column, if it's text, you know that it's text for that column. So we now look at identifying outliers. So outliers basically are like values that are like extreme from the original, like the values that you have. So extreme high or low values. So if like your values is in the range of, let's say, 15 to 30, but you have one value to be 100,000. That 1,000 seems what it looks like what that 1,000 is an outlier. An example can be age. Having the person to be 200 years old is an outlier. And these are all caused by the normal, what I've said earlier, the data entry, and some too by fraud and other sensor failure. So let's say with the sensor failure, if you go to hospital, the thermometer reads extreme high value, but on that day you are good. It doesn't show that you have that high fever and stuff, but the thermometer reads something else. And this is very important because it misleads our decisions and it affects our accuracy. So how to detect outliers? For example, a large data set with like almost like 3,000, 4,000 observations, it's very difficult to now be pinpointing, like looking at each rows to see where the outliers are. So we can use the z-score to check whether the outliers are outliers or not. So with the z-score, when you take your bell curve,
It's not gonna show.
it won't show. Oh, okay. So when you take your bell curve, most of your data should be within the 1 to 3 standard deviation. So that's where 99.7% of your data is supposed to be. So if your data is really at the extremes, then it's indicating that there's a possibility of what? An outlier. And another one is what? Your box plot. You can also use the box plot to show. And the box plot will show whether there are outliers with the asterisks showing that those are outliers. And these are how we calculate it manually. But if you are using software can calculate it for you and like shows you a visual picture of the box plot, indicating whether there are outliers or not. And if your data involves relationships, so like sometimes scatter plot can also detect if there are outliers. So how to handle outliers? It's either you remove them. So for like age to be like 200, then means that particular thing is an outlier, you have to remove it. Or you have to cap or floor it. So for example, you cap it at, let's say, 5. If you take a salary, and I'm saying that all salary should be from 1,000 to what? 500,000. So all values after 500,000 now becomes what? 500,000. So to be able to cap the outliers. And with this, you have to be have to be careful. Sometimes it's real and important, so you don't need to remove it, but all that you have to do is to keep it. And sometimes you can transform your data to reduce the impact of outliers using the log transformation, the square root transformation. Sometimes your data may not have outlier, but may have missing data. So missing data, some of the cells are empty. And with that, we have the types to be missing completely at random. So with them, you are safe to drop it. Maybe you take like a test, data from external source, and there is no pattern, there's nothing to show that there was something there and mistaking it is off. So with them, you just completely take it off. And you also have missing not at random. So strategies to handle missing data. One is either you remove them or you replace them. So one way of replacing them is you take the mean of that column and you replace those cells with the mean or the median. So if your data is more like skewed, we expect it to be like replacing them with the median and stuff. And also you can also retain missing data when it's appropriate. You can highlight them and make sure that, you go back for the details and kind of fill it in. Or you can use a multivariate imputation, that's a KNN, the nearest neighbor. So you check for it and see which value would be good to use. So there are some things you have to ask yourself when using to make decision whether you have to maintain or whether you have to retain or remove. So one thing you have to ask for yourself is that, is the value realistic? Is this value that I'm going to delete affect my analysis or not? So if it will affect it, then probably you have to retain it and modify it by using the mean or the median. If it's not going to affect it, then you can it's safe to remove it. One thing you have to look at is that we shouldn't remove too much data. For example, if your data set is like 10 and all these are very important and you are removing like 5 out of it, the rest of the 5 that you're using to make decisions may not be conclusive. So it kind of affects your decision making if you remove too much of your data. And also when we ignore important observations. And sometimes too, when we clean without justification. So with this, when you are cleaning it, you have to look at all the rows. You don't just pick one cell and clean that particular cell. Then it means that the rest of your data set become inconsistent. So we'll take some live demonstration of how to apply it in our work.
Okay. Does everyone have the R pulled up? So you can send it to the chat if you don't see this. Please let me know if you can see this. So you can use R as a free software. You can use R in 2 different ways. So first, can you see? Good. So you can install R. This is the internal codes for the R, and then you can use the R Studio, and the file we send it today, and you can open them up from here. File, open file, and you can just open them, and you can click on them and you can just open them. Are we on the same page, everyone? Okay, no negative chat, no nothing. Okay. Also, if you don't have R, because I saw a few times people don't have R, so you can just go on this link and you can open an account. It's free and you can easily do it. So I can show you that one too. And let's see. Find the screen sharing option. So where is it? So it looks something like this. You can just put your email and password. Okay. So it's gonna look like something like this if you want to do it online. So you just go there and you start a new R project. And it's gonna take a few seconds. It's taking more than a few seconds. So yes. Yes, so it's gonna look like this, exactly like the thing we have offline. So you go there, you just upload your file. Okay. So I'm for this. Okay. So thank you, Timothy. Okay. So now I stop sharing this file. I'm gonna share our local R studio. Okay, there's. So this type of file called R Markdown file, you can write code and any comment you have in the same place. Okay. So we are good. So the problem is before cleaning any data, we need to know what our data is. That's very important. It's called domain knowledge. So for this demonstration, we are using New York City data, air quality data from 1973. So it has few like common problems that real world data has. So it has duplicate observation, it has inconsistent formatting, it has some outliers, also it has some missing values. So this is a common saying in data science: if you put garbage in the model, you're gonna get the garbage out. Okay. So our goal is to find and remove the duplicate records, fix the inconsistent text, and detect and handle our outliers and deal with the missing variable or missing values. So we need to have this package in R. So packages are like apps on your phone, because the R is like your phone and these packages are like the apps. So you can download different apps for different purpose. So for this demonstration, we need this package. It's called library.tidyverse and then this one. Okay. So if you never use this one, or if you never use this library, you have to remove this hashtag in front of this two command. So this two command is gonna do, they're gonna install this package on your machine. But once you install it one time, you don't have to install it again. Okay. So since I have it, I'm just gonna make it like a comment. So when you comment something, it's not gonna execute in R. So to execute, we can just press here. Everything is good. It has all the package. If it didn't have the package, it's gonna say this is missing. Okay. Next thing we need to do. Let's see. Are we on the same page? Okay. So next, we are gonna read our data. So there are few ways you can read your data. You have to have in the same directory the file and the data. So this one, so df is called data frame, it's short for data frame. And this one, this sign So you can just write it like this. So you use less than sign, and a dash. Okay. So this sign is going to assign our data set in this data frame. Okay. So read.csv is a common way to read CSV file. So you can just run it, and it's going to have our data set in the df variable. Also, if you don't know where you save your data, you can just use this command. So let's say what happens. Let's first do it as it is. So yes, our data was correctly stored in the variable, and we can see all the variables in there. Okay, you don't have to worry about this part, but you can see that our data is in there. Okay, let's say you don't remember where you uploaded. Now, I'm gonna do it in a different way. If you run it like this, read.csv, but instead of naming the file, you can just write file.choose. So if you run it, it's gonna ask you the data set. So you add this one, and you can just add one. Sorry, what? Okay. So either way, you can read the data. Okay. So I always find this one easier because if you have many files, you can just run this one. And head df.10. So what does this line does? It just shows the first. So if we didn't have anything like this part, like 10 after comma, it's just gonna show us the head of this data set. So when you mention tens, it's gonna show 10 data set, 10 data points. And it's a common for Python as well. It's head and .df, okay? And you can mention how many you want. You want 10, you want 12, whatever, okay? So this is just to show the data. So if you look at the data, we can already see there are a few inconsistencies in there. So we can see the ozone is 999. And we can also see there are few NA. So this NA means they're missing variable, not available. But since we can see all the variable or all the data points, we have to do some more digging, okay, if there are any inconsistency in there. But ozone, if you don't know, it should be less than 200. It's ppp or something. Also solar is also radiation. It's always less than 300. Okay. So this is just from the domain knowledge. We know that. So when you work on a data, you should know what kind of data you are working with. So if you have no idea about the ozone or solar, then all this data would look like right to you. But that's why you need some domain knowledge when you're working on a data. Let's do, so androw df, what androw does, it shows you how many rows in there, number of rows. That's why it's called androws. Androws and column, number of column. So if you run these two, it's going to show you that we have 161 rows and 7 columns. Okay. Next, we can use glimpse.df. So it just gives you a glimpse of the overall data. Okay. So you can see there are some NA values, and you can see the month name. Okay, so this is just give you a glimpse of the whole data. So it's called glimpse.df. So df, you can, if your data was in a different name, you can put different name in there. So you don't have to put df. So this one, we can see quick summary. So this one is always really important. Sometimes people call it like 5-point summary. So this is always important when we analyze any kind of data. This is the first thing we do all the time. So it's gonna show, okay, this is our variable ozones, this is our variable solar, this is our wind. Sometimes it just like, okay, and wind, temperature, and month. There's some overlap, but it's mostly visible. So for the ozone, we can see our minimum is, okay, messed up the whole thing. Okay. Either. But if you look, okay, it's all messed up. Okay, so sometimes it's gonna show you in a more like columns, like distinctly. Sometimes it just do it for some reason. I don't know, maybe I can somehow make it bigger. So if you look at the ozone, and if the max value of the ozone is like 999. Okay, for the solar, our max value is 334. Our temperature max value is 212, 200. Okay, and our so we always look for minimum, how much minimum values in there and how much maximum values in there. Minimum value, maximum value. We also look for the median. We also look for the mean. Okay, so we can see that we can already know that there are few, these two at least is kind of outlier, because our mean is 77, we have 200. And for this one, if you look at the mean is 46, but we have like what? The maximum value is 999. Okay. So do you notice anything unusual? Our max ozone is 999 and minimum temperature is minus 30 degree. So minus 30 degree is good for Antarctica, but in a summer time in New York, it's not good. Also, we have stubborn and not available values. Okay, so we can just doing the 5 point summary and just look at the data. We can see few inconsistencies in there. Next, we're gonna check for the duplicate rows. So these are the duplicate rows for one reason or another. They show up in our data. It happens all the time. So this one, duplicate.df, is give you like duplicate variable from data frame. And when you sum up, they just sum up all the from like 1 to whatever duplicate value you have. So we can see we have 7 duplicate value. Let's see, let's try this one. Okay, no, I'm not gonna try this one. I'm not good with Windows, so that's why I was not. It's Control C. So it's just gonna say true or false when there's a duplicate values. Okay, so that's why just writing it like duplicate df is not very helpful. But when you sum them up, you see how many numbers are in there. So we know there are 7 numbers in there. This is for the duplicate, sum duplicate output is 7, and this is for just for the duplicate. Okay. So we can also see how duplicates rows are. So for this, okay, so anytime you see the square bracket in R, it usually means you want a subset of something. So there is a square bracket and there's a square bracket. That means we want some sort of subset of this. Can you see my cursor? The zoom. Okay. So we want some sort of subset of data frame. Okay, and it has 2 parts. This part is for the row, and after comma is the column part. So we don't need to do anything for the column. We just need to do anything like something for the row. So what it does is duplicate df and duplicate df from the last. Okay, so it goes through the duplicate from the top and also go duplicate from the bottom. Okay, and both of this is true. This this sign means when both of them are true, it's like a OR sign. In real life, if either of them is true or both of them is true, it's going to be true. Okay, so we can see that 20 is our ozone. We also have 20 in our ozone. And you can see 22. Okay, you can see 40. So these are our duplicate row. Okay, so 199, 199, 168, 168. Okay, so next thing we're going to do, we're going to remove this duplicate. Okay, now the way you do it, you just write distinct df, and it's going to make them distinct. Okay, it's not going to take any duplicate columns. So now df, now if you look, we have 154 rows in our data set. Okay, so far so good. Does anyone have a question so far? No? Okay. Next, if we look at this one, we can say May, June, July. In the first look, it looks right, but we usually write all the data, most of the data has our variables in May in a capital letter and A and Y is a small letter. But this one is the start is a small letter and this one is all cap. So if you wanna like count, when you see it in real life, you can count them by hand. But the machine doesn't know the difference between June and July, especially because this kind of programs, the new programs, they're case sensitive. Okay, so that's why we need to make them all the same way, the same format. Okay, to do this, we can use this command. So that way this command works. So anytime you put like $sign plus something, it means you are taking that variable from the data frame. So here I am saying basically that go to the data frame and take the month name. Okay, this is what this $sign means. Okay, and on this $sign assign, so is string to title. So it's gonna make all the name, the first letter is capital and every other is small letter. So string to title is gonna put anything you have, is gonna take all the word and it's gonna take the first letter in capital and everything else in small letter. Okay, so we're gonna do df, we're gonna take df and the month name. So that's what I said the $sign does. So df from month name, and we're gonna convert all the df and all the month name from the df to string to title. Okay, and we're gonna store them in month name. Okay, and unique.df is gonna show you now all the unique variable for the month name from the df dataset. So month name $sign means from kind of, and df month name from the df. Okay, next we go to the outliers. So outliers can be the normal range from your data, but you have to be careful. So this is kind of messy, but it's not that hard to do. So we are just using ggplot. So I'm not just gonna delve into the ggplot, but this is the most important. So df, and it's gonna select all the ozone and solar, wind, and temperature, because we cannot plot any value that's like character. Okay, that's not numerical. We can, if they're not numerical, we can print them with a box plot. Okay, so if you look at the data set, so you can, so I just try to make it more, excuse me, style. So that's why I had all this command, but you don't need all this. Okay, so if you look, the ozone it has this red sign, it means it has outliers. The temperature also has some outlier. The solar and wind, it doesn't have outliers. Okay. So the red dot in ozone and temperature are clearly errors. A value of 999 and degree in New York is not possible. Okay. So how do you deal with G-score? So how do you deal with outliers? Because we cannot see like, okay, from this block spot, it's say, okay, what these values are. But how do you definitely know which one are outliers? So to know which one are definite outlier, we have several methods. So one of the common method we use is called Z-score method. So I don't know if you see my board. Can you see my board? Okay. So the Z-score is going to be like x minus mu divided by standard deviation. Okay. So x is our values, mu, or we can just write x bar. Okay. So x, the regular data, plus its average divided by standard deviation. Okay, that's the Z-score. Okay, so when we have Z-score, we do this with the duster. Okay, never mind. So I'm going to write it again, x minus x bar divided by standard deviation. So if a data is more than 3 standard deviation, we call them outlier. Sorry, more. If the absolute value of this z, we call them outliers. Okay, if z is greater than 3, we call them outliers. Okay, as you can see from here. So this is what we did. So first to you can I'm sure there are some package but they have like function, but here I just did it like manually. So first I had to calculate ozone mean. So we're gonna take the ozone from the data frame, and we can, if they're missing, we're not gonna do it. It's just not available. If they're not missing, we're not gonna do it. We only do it when it's not missing. Okay. So we're gonna make that. We're gonna also have standard deviation. This function find the standard deviation of this one. Then we're gonna create the Z-score. So as I said, this is our x. This is our x bar, the mean, and this is our standard deviation. Okay. So if we have any value that's greater than 3, is gonna be our, this is like a common number we choose. So if it's greater than 3, we're gonna say those values are outliers. Okay. So this, what this line does is and a. If this one and this one, the absolute value of G-score is greater than 3. Okay. Is G-score is available? If it's missing, it's not gonna do that. And if G-score is greater than 3, we're gonna call them outliers. Okay. And we are just merging these two in our data frame. Okay. So our ozone, we can already find when we use ozone, we have a outlier. The entry was 999, and our ozone score, ozone G score is more than 10. Okay. So we want our values inside the 3. Okay. So when they're more than 3, they're most likely to be outliers. Okay. This is one way to do it. There is another method, is called interquartile range. So this is our, so I'm used to writing on the board. So if you have a data, if you divide them in 3 parts, so this one is our Q1, Q2, Q3. Okay, so this one has 25% of the data, and this one has 75% of the data. Okay, so Q1 and Q3, and then the difference between Q1 and Q3 is called the interquartile range. So you multiply the interquartile range by 1.5 2 times. Okay, then you add. So basically, you are adding something at the end, and you are adding something up. Okay, so anything that falls that outside, anything that's fall outside of this range is gonna be outliers. Okay, if you can see the board, it would be easier to see. Okay, so Q1, so we're gonna write this one. So Q1 quantile. So we're gonna take ozone and we point to 5, and we're gonna, if they're available, if they're missing, we're not gonna do that. So we're gonna just find the Q3 minus Q1. Okay, so here we calculated the quantile Q1 and Q3. Then we just subtract them to find the interquartile range. Next, for the lower bound of interquartile range, Q1 minus the whole thing, 1 point of IQR, upper bound, Q3 plus 1 point. It's just giving you some buffer zone. Okay, you don't want any all the data between in the interquartile. Okay, so this just give you extra buffer zone. Okay. Okay, so for the ozone, we found these are our outliers. Okay, using interquartile range. Okay, now we're gonna go to the next part. How do you handle outliers? So you can always remove them, but this is not a good idea. Our professor always gives this example. If Jeff Bezos come to Elizabethtown, everyone's gonna be a millionaire. Okay, so but you have to do in a separate way to countermeasure it. Okay, you cannot just remove it. Okay, so you can just, so one of the easiest way to do, just remove it. You can cap it, you can keep the value. Okay, if 2 or 3 billionaire lives in Elizabethton, you have to keep them. Okay, are you good so far? Someone said something. Okay. So we are removing all this outlier. Now we see our data row is 150. Okay, you can also cap them. By capping, I means if you know the exact range, you can put all the data in that range. If you say, okay, if any data is outside that range, we're just going to remove them because those are not realistic data. Okay, so quantile, and there are a few other ways you can cap them. So this is one way you can keep them. So max, ozone, P99. So this is just forever. Okay, original ozone range in 106, capped ozone range in 106. Okay. Next, we go to the missing data. So as Sachi said, you can have missing data in a few different ways. So missing completely at random. Let's say you are inputting some data in your data set, and somehow your cat worked on your keyboard. So you lose the data, okay? Because it's completely at random. If you're writing the data on your paper and you're having ink smudge, then it's also like completely at random. There is no relation to other things with that one. And MAR, it means missing related to other variable, okay? For example, if you ask people income and they're really young, if they don't have a job, then the income variable is gonna be missing for younger people. If you ask a kid, okay, what's your income? He doesn't have any income, so it's gonna be missing. Okay, so but if you had another variable called age, and you have this one missing, then there is a relation why they're missing. So the first one, we didn't have any relation why it's missing, but for MAR, there is some relation. It's related to other variable. Okay, So you have to, so when some, and there is another one, missing depend on the value itself. Why something is missing? Okay, it's missing. It not depend on other variable. It's just missing by its own merit. Okay, if you ask someone, okay, how much income tax they paid, if someone is rich, they're not gonna say it. Okay, so if you drop down those kind of variable, you're gonna have some bias. Okay, and if missingness is related to other variable MAR, then you cannot just drop them because they're related. Okay, and for this one, just for MCAR is the only one who is like safe to remove. For the other two, you have to be careful. And for other two, you can impute by knowing other variable. So MAR missing is related to another variable. This is the easiest one to impute. Okay. For M and AR, this is not that easy to impute. Okay, because it still can create biases in your data. So to deal with the missingness, you see, okay, how much data is missing. Okay, so the ozone is only at 36 missing, the solar radiation has 7 missing, wind has 3 missing, and this other two variable doesn't have anything missing. Okay, so what's the percentage of the missingness variable? Here I just, is NADF is missing, is NA, just find the missing variables and you just divide it by the row, number of row, and you multiply by 100 and it gives you the percentage, and this is for the column. Okay, so we have 24%, 4.7%, for wind is 2%. Okay, these are the missing variable. Okay, and you can also visually map them how they are missing. So we can see these black labels, these are missing variable. Okay, this black, they're showing the missing variable. In the ozone, in the solar, we have missing variable. In the wind, we have two missing variable. Okay, there are many other different ways you can visualize the missing variable. So ozone has the most missingness, but is it a MCAR, MAR, or missing not at random? Okay, so one clue you have, when high ozone tends to be hot. So when ozone is high, it means the temperature was hot. So if you see consistently that you are missing the ozone variable, and there is also the heat was up, the day was really warm, and in those days you are having this ozone variable is missing. So of course there is a relationship between them. Maybe because when the sensor you had to count the ozone, it just got burnt out because of the temperature. Okay, so you have to figure it out in your data. So this one, it just shows, okay, if the average temperature is 77, like how many are the missing? Okay, but if that average temperature is higher, how many of them are missing? So you see 36 of them missing when the average temperature is higher. Okay, so of course there's a relationship between them. Okay, so you have to be careful when you count it, like if you wanna leave them alone, if you wanna just remove them, if you wanna input them. So when it's MAR, not completely random, you have to impute, and it's a like easy thing to do with R or with Python. Okay, this is just for the, I'm just missing grammar, don't worry about it. So rows before moving was 150, rows after moving, not available video is 107. Okay, data loss is 47% row. So here is another dilemma. If you have missing variable and you just remove them, then it's gonna be costly, because if you lost like 20 or 25 or 75%, like 40% of the data, then it's not good. Okay, so removing 20% of data can reduce statistical power and introduce bias in your data. Okay, so in those cases you can impute them. Okay, so there's one, the easiest way to compute is mean and median. So you can look at a row and you find the mean or the median, then you can just input all the missing variable with this one. And this is easiest thing to do. Here we are imputing few variables. So here we are imputing using mean, sorry. Okay, and you can do either of those. So now all this variable, they don't have any missing variables. Okay, it's simple and fast, but it reduces the variability. It ignores the relationship. So you have to, when you do median or mean, you have to be careful. Okay, because if the student was like really bad and everyone has a average grade of 78 and this guy was missing and you just put 78 in there, so you have to be careful. And there is another one is called KNN imputation. This is a little bit better. I'm not going to go into the math for K nearest neighborhood, but basically if you have few rows, let's say, and you have ozone and temperature and other variable, okay, let's say wind. So this only this one is missing, but you have variable for this one, you have variable for this one, you have variable for this one, and let's say this one is also missing. Okay, then it's gonna compare the other variable and see, okay, which makes the most amount of sense. Okay, so it's gonna look all the neighbor and which one makes the sense. So you can also define how many neighbor you want. So here I have k equal to 5. Okay, it's gonna look for 5 neighbors that are close to that missing variable, and depending on that, it's gonna impute that variable. Okay. And this is another BIM package. Sometimes, okay, oh no, it did correctly. So it imputed ozone, wind, and temperature into KNM. Okay, so the summary is, we are done with our demonstration. The summary is, so if you have duplicate, you can remove them. Okay, if you have inconsistent, you standardize them, and if you have impossible outlier, you just remove those. Okay, if it's natural outliers, okay, then you identify them using interquadrant range or the G-score, and you keep it. And if you still have missing variables, and it depends on what kind of missing variable there is, you can impute them using KNN or median or mean. Okay, but as always, as I said, you have to always be careful how much variable you are reducing. If it's too much, then you just cannot remove it. Okay, also if it has missing too much variable, then you can also not gonna impute it depending on the weight of the variable, because it's also gonna bias the data. Okay, this is just some standard procedure. And yeah, let's conclude my R. Don't have any time to do. Okay, so we don't have any more time to do a demonstration on Excel. It always happens. But if you like, if you wanna do a survey in our website, you can just scan this QR code to do a survey. And if you have any question regarding the SCL or regarding the workshop, you can reach out to us, and we're gonna try to help you as much as we can. And do you have any question? Does anyone have any question? And do you guys need any time to Okay, so if
So with the Excel, because we do not have enough time,
yeah, I said it.
we'll in the slide that we share on Monday, we'll tell you how to do it with your data that you have. So please be rest assured you get how to do it in Excel on your own at your own pace. Thank you.
Can you show us the summary? Okay. Yes, of course. Let's see. Which summary are you talking about? This one? Let's see, control. Okay. This is the summary. Okay. Do you have any question regarding the summary? Okay, thank you. Okay. So if no one has any question and no one have any comment or anything or any suggestion, how can we do it better? We're gonna end our presentation. And thank you so much for coming. You can always reach back to us. Thank you. You guys have a good day. Thank you.